we can organize our data in a more structured way, no pun intended, so that we can instantiate, we can create multiple elements, multiple sets of data. Instead of just creating an array full of strings that were people's names and then another array full of doubles that were their salary and stuff like that, and then another array full of some data type that was their birth date, and you have all these multiple arrays. You could make an array of a specific kind of structure, and then that structure would contain both the person's name and their salary and their employee ID or things like that. So I'm just going to demo this. Go ahead and create a new file, new project. And we're going to cover 3 different types of way of organizing data. One is an incredibly inefficient way, or it's the least useful. And then the next is better. It's the struct class. The struct, or not class, the struct keyword. The struct keyword dates all the way back to the invention of the C language in 1970. It's a nice and handy thing to do. However, it's been superseded by the class keyword, which allows you to attach functions, methods, to a data structure. So a namespace. We keep doing this using namespace thing up at the top, but I don't know if we ever gave an example of a namespace. So up at the top, I'm going to make a namespace, and I'm going to call it person. So namespace person, and I've decided that every person needs a name, and every person needs an age. So down in my code, when I want to fill in those variables, if I want to use them, I have to follow a special syntax, which we've seen just a little bit. Remember when we've seen those colons in front of like cout and cin if we did not using namespace std? Well, that's how we have to preface variables that are declared in a namespace, unless we do using namespace person. So I could do this. Person : name is equal to Freddie. And person : age is equal to 30. Now, why would you do that? Well, it makes the data a lot more readable. You can also put functions in the namespace. We could put a whole bunch of different functions up in the namespace, and in order to call them, you would have to preface them with the namespace followed by 2 colons. So let's add a hello function to our namespace. Void hello, parentheses in parentheses, cout, hello, followed by the person's name, followed by indel. I'm going to condense my code a little bit by moving the braces up to the same string, the same opening braces as the line above them. So after I've set the person's name and their age, I'm going to do person : hello. And that will print hello, Freddie. So why would you do that? Well, if you have thousands of lines of code, it could just make it a lot clearer that you're referring to a person's name and a person's age and a person's, whatever, if you define them as part of a namespace. And namespaces are particularly useful if you have a whole bunch of different functions that might have the same function name. What if you write a class, or what if you write a function called output, and you know what you're supposed to send to that output? You know what it's supposed to do. But then somebody else takes your code, and they want to add an output function. And then somebody else takes their code, and they want to add an output function. Now there are 3 different output functions in the code. Well, If you put each one in their own namespace, then it becomes very clear what you're outputting. Person.output, printer.output, you know, geometry.output, whatever they are. So you can distinguish between sets of variables and sets of functions by using a namespace. Now say I really got tired of having to preface everything with that colon nonsense. I could do using namespace person. And now I don't have to. I can just say name is equal to Freddie. I will remove one of those just to prove that point. A lot of people don't like seeing that using namespace. It saves a lot of typing, but if they're looking at code, they'd like to see what namespace those variables and those functions are located within. And you're masking a bit of data from somebody if you have using namespace. So it's perfectly fine to use namespace, but that is why sometimes you'll see examples of code posted online where they did not do using namespace std and they preface everything with std : : a bias against using namespace. Okay, so that's one way of doing it. We have gathered some data, 2 pieces of data, and a function that acts upon them. And we have given them names in such a way that we can treat them, you know, person age is 30, person name is Freddie, and then we can say hello to that person. So we've done some of the stuff that a class can do. However, what happens if you have more than one person? That really doesn't work. What are we going to go up there and do? Are we going to create a second namespace called person2? Or are we going to add some variables to our person namespace, name1 and name2 and name3? It gets kind of messy. A namespace is really not a good place to create a data structure of the type that we are working with. So, I think what I'm going to do is I'm going to hit a whole bunch of returns right there underneath main. And then above main, we're going to take our next stab at creating a data structure. Because namespaces aren't perfect. And if y'all just came in, you missed the lecture on namespaces, but just carry on from here. Create a new project. Add, you know, an IO stream and string and using namespace std. And now we're going to do something called a structure. A structure is a way to cluster pieces of data together. You might declare a structure, you know, like an internet packet. An internet packet has, you know, all these different fields in it. Let me show you what a TCP packet's structure is. Like this. Inside each internet packet, and your machine is sending thousands of these a second, you know, is a number for the source port, the destination port. You may know what those are, you may not, that's okay, you know. And then all these other fields, all these other little bits of information, and finally some data, you know, which is just a small fraction of the data. So if you're sending somebody, you know, an email, it may require 10 internet, it may require 10 packets to create it, it may require 100 packets or whatever. But each packet has its own source port, its own destination port, its own sequence number to keep track of the order in which they get sent, and their own data. You could create a structure in C that would duplicate this, that would mirror this. Now we're not going to do this, but that's the idea of a structure, is it's just got various places where you put various pieces of data. Now we're going to make a structure that has a person's name and their pay rate, the hours they worked, something like that. So here is the word struct, and I'm going to call it EMP, short for employee, and I want 3 fields. One is a name, and then maybe an hourly salary, hourly, and then maybe one more called wage. And then inside main, I'm going to create an employee. EMP Bob, semicolon. Bob's name is equal to Bob. Bob Johnson. How's that for a car dealer sounding name? Okay. Then Bob.hourly. These two things duplicate each other. How about just hours? Double space hours and double space wage. And so his hours, Bob works 90 hours a week. He's a freak. And then Bob.wage is he earns $10 an hour. A structure cannot have functions attached to it. So if we're going to use this data, we just have to deal with the data in a way that we have been. We have to deal with it right in main, or we can write a function, and put it above main or below main or in a separate file. So let's create a function that accepts an employee object and prints out that person's salary. So I'm just going to call it void, and I'm going to call it output, and it takes an EMP object, which I'm just going to call E, and I'm prefacing it with an ampersand so we actually get a reference to that object rather than passing the entire object on the stack. That saves a little bit of memory. It's a little bit faster. Not that that matters. Okay, and so now I'm going to see out the person's name, E.name, followed by a space, followed by their hours, followed by another space, followed by their wage, followed by E and DL. Let me see how much of this I can get back on this screen at one time now. And instead of doing E and DL, I think I'm going to also output their total salary, which is E.hours times E.wage, and then E and DL. Now I broke that into 2 lines. You don't have to do that. It's not liking the fact. Okay, here we go. There we go. Now, why is this a superior solution to using namespace as a way to organize your data? Well, you could create as many employees as you want. With namespace, we could only, have effectively that one namespace. We could only, keep track of one person's name and their age or whatever we were keeping track of at a time. But with a structure, we could create, 100 employees or 1,000 employees. We could add them all to an array, or some other kind of a data structure, a list or a vector or whatever. We could deal with them as a large collective of data. And you can see that it's easy to keep track of what bits of data you're looking at. You know that you're looking at somebody's name. Whatever dot name is equal to that. Whatever dot hours is equal to that. Whatever dot wage is equal to that. If we created a second variable called Sally, we could do EMP space Sally. Sally's name is Sally Johnson. Sally's hours are 120. She works even more than Bob. Sally's wage is 20. She earns twice as much. Okay, so that is an example of using a structure. Now, all of these members are accessible down here. I'm calling them members. All of these member variables, I'm calling them members because they are members of the structure. They're accessible down here. That's why I could do bob.name. If they were not accessible, I couldn't change them down here. How do you make them non-accessible? Not that you would do this for a structure, but you can. You can put the word private colon in front of the member declaration. And that makes it so that name is now private. I can't even change it. Why would you do that? You don't do that for a structure. The idea behind a structure is that you're going to list a whole bunch of member variables and then you're going to change them inside, of the client code. If you hear the term client code when you're talking about structures or classes, the client code is the stuff that goes in main, that uses the data. And it's not a client-server relationship where you have two computers going on or anything. It's nothing so complicated. It's just the code that actually uses that structure. And if you make your data members private, then your client code no longer has access to them. And so that's why .name is giving me a red underline to indicate that that no longer works. I'm going to delete that. Don't like that. Alrighty. So everybody got this part working? If not, I want to help you with it. And then the next thing we're going to do is we're going to change employee into a class, and we're going to make this output method a part of that class. Are we all good? Anybody? Okay, so to create a class, it's very similar to creating a structure. At its bare minimum, you just replace the word struct with class. However, I don't want to just completely do away with our word. So we're going to make another one called class, and this is going to be EMP with a capital E, just to distinguish them. And there is a naming convention, a variable naming convention, that says you name all of your classes with an uppercase letter. Now, it's absurd to have two different things with the same name that only differ by whether they're uppercase or not. But I did that so that I could keep this structure rather than, comment it out or something like that, or come out with a completely different name. Not sure if it makes sense or not. Okay, so I'm going to do the word public, and then I'm going to add the same variables. String name, double hours, and double wage. Why did I add the keyword public? Because by default, the data members in a class are private. Whereas by default, the data members of a structure are public. So if I did not have the public keyword, then the client code, after it creates an employee, could not access employee.name or employee.hours or employee.wage. But by adding the public keyword, I was able to do that. So now that I've done that, again, I'm going to space all this stuff that use that lowercase emp down just to get it out of the way. And I'm going to create an uppercase emp. This one is going to be named Joe. emp Joe. Joe.name is equal to Joe Johnson. Joe's hours, 40. Joe works really cheap. He makes $1 an hour. Now we don't have an output function yet for this. And we can't pass this function to the output function that we wrote that accepts a structure, because it's a very different thing actually. A class is not the structure. And even if they had similar names, that it doesn't treat them as being the same at all. So I want to add another output function, but I want to actually make it part of the class itself. So underneath wage, I'm going to do this. Void space output, and I'm not going to give a variable name. I'm not passing in a variable name because we're actually inside the class. So we have access to all those variables that are defined within the class. So we're not passing in a reference like this. And inside it, we're going to do the same thing we did up here. C out our name, followed by a space, followed by hours, followed by a space, followed by the wage, followed by hours times wage times E&DL. Now I want to invoke that function. I made an employee called Joe. So after I set his information, I'm going to call Joe.output. Joe.output.
Is that a second main function, or did you remove all the Bob stuff?
I kept hitting return to push it all down.
Oh, okay.
Yeah, so here's my Bob stuff, and then later on is that Freddie stuff at the very bottom. I like Fiona Apple, by the way. I approve your shirt. You get a
Thank
bonus.
you.
Alrighty. So, you know, our program is kind of filled with leftover junk. We're still printing stuff about Bob and Freddie, but I hope you're seeing the difference between using a namespace, using a struct, and using a class. A struct cannot have functions attached to it. And that's actually a lie. A class has both data and functions in it. A struct is supposed to just have functions, data. Now, honest and truly, the keyword class and the keyword struct do the exact same thing, except it can, by default, everything in a class is private, and by default, everything in a struct is public. So, the word struct is a holdover from C. And they kept it in a language, but they made it identical to a class with that difference. But conceptually, if you're going to think about something that only has data and no functions, you could think struct. If you ever go back and modify C code rather than C++ code, if somebody has written structs, that's what it is. A struct is a data format which has named members that can be set, you know, to different values. Okay, so we have an output function here. We can invoke it here. This is getting pretty cool, but it would be kind of neat if we could do this. Employee Jill, parentheses, and her name is Jill Johnson, and her hourly, she works 40 hours a week. If you type in this, great, but it's not going to work. And her her hourly salary is $12.50. That would be neat if filling in all the data was as easy as doing that. That doesn't work, but it can be made to work. There's something called a constructor, and every class has a constructor. The constructor is called when that variable is created. So when we do imp space Joe, the constructor is called, and all it does is nothing. I think it sets these numbers equal to 0. You know, that's really all that it does. That's known as a default constructor. If you say emp space Joe or emp space whatever the variable name is, but you don't have parentheses and you don't pass in any values, the default constructor gets called. Now behind the scenes, every class that you write is given a default constructor. But you can write a custom constructor, also known as a parameterized constructor, that accepts parameters when that object is created, so that you can fill in that data all in one fell swoop, rather than waste 3 lines here. So we're going to add a constructor. And what is a constructor? A constructor is a method that you attach to the class, that you put in the class, that has the same name as the class itself and no return type. See, this function had a return type. We declared it as void because output didn't need to return anything actually, but it had a return type. But now we're going to add a constructor. It has the same name as the class, but it accepts variables. It accepts a variable, let's just call this one in for name, and then accepts a comma, and then a double called H for hours, and a double called W for wage. And it sets the members to these values that are being passed in as arguments, as parameters. So we're going to say name is equal to N. To get all this to fit on one line, I'm going to do the unthinkable and put more than one line of code on the single line. So hours is equal to H, wage is equal to W. Now that I've done that, the code no longer compiles. This line that said EMP space Joe down there at the bottom, it used to work fine. But by adding a constructor, it no longer works. And the reason for that is that C++, along with Java and a lot of other languages that kind of follow the C++ syntax, once you add a constructor, the default constructor is no longer provided. And that means that this syntax no longer works. For this to work, we would have to add the parentheses and some optional fields. If we wanted to create an empty employee, it would look kind of like this. Don't do this. You know, like that. I don't want to have to do that if I'm not actually setting any values. That just makes it confusing. So we're going to add a default constructor. And it's not going to do anything. But a default constructor looks like a constructor. It has the same name as a class, but it just doesn't have any parameters between the parentheses. And it doesn't do anything. So there we go. There's our default constructor. I'm going to put a label on it. Default constructor. And I am going to call this one constructor. Its official fancy name would be parameterized constructor. It's nagging me that this textbook calls it something slightly different. We'll see when we get the PowerPoint. Parameterized meaning you're passing parameters into it. Now that we've done that, this line of code down here works again. EMP age. So whenever you add a constructor to a class, you will be breaking all the code that currently uses that class. If there is any code that uses it, unless you go back and add a default constructor yourself. Now you can make the default constructor do something other than nothing. If you wanted to make the default constructor set the person's name equal to unknown, and their hours equal to -1, and their wage equal to -1, you could put all that inside the, the braces for it. But we're just going to leave it like that. Okay, so we have two ways of creating employee objects now. I'm using the term object. An object is what gets created when you use a class name followed by a variable name. This is called a Joe object. Excuse me, it's called an employee object. Last week I used a simile that a class is a blueprint, and then the variable that is created is the house that's made from the blueprint. So EMP, our class, is our blueprint. It tells how to do it, but this is actually the object that gets created from that blueprint. You have one blueprint, you could create 100 objects of the same type, or 1,000, or 10,000. I messed something up. There we go. Okay. So now I've created two objects. Why not create a third one? Employee, Sam. Just go nuts and create like 5 different people. Okay, so now I have 5 different objects that I've created. You may wonder why I'm giving it a name of Job and then I'm setting its name equal to Job. Well, the variable name is just for the use of the program. We could have called it X123, or we could have called it, Hogwarts is awesome, or completely stupid things. We could have called it EMP1 for employee 1, EMP2. The name of the variable is divorced from the contents of that variable. So if I've been thinking a little bit more clearly, I would have called them, like employee 1 and employee 2 and employee 3. But, it's kind of nice also to see it in that format maybe. So I have these, excuse me, values. I want to create an array and assign these values to the array. Let's see if I can do that. I'm going to say EMP, and I'm going to call it people. I think people is probably a bad word. I think we already called somebody. No, we called that person. Okay. People. And it's a list of 5 people. Excuse me, 5 employees. So we're going to say that people 0 is equal to Joe. People 1 is equal to Jill, or whatever you made your variables. So now we have one data structure that actually holds the information for 5 people. That data structure, that array, has 3 pieces of information for each employee. So it's really tracking 15 bits of data, 15 pieces of data in one data structure. So next we want to create a function called print paychecks, or maybe just paychecks, that will process that array. So I'm going to do this, paychecks, and then I'm going to pass it people. Now it's underlining that because I don't have a paychecks function yet. I'm going to do some deleting that you don't need to do, or not deleting, but putting stuff on one line that you don't need to do in order so that I can write the paychecks method right above main. Void paychecks, and it takes a reference to the array, which is an array of employees, EMP people. And now let's use a for loop to print out each person. So for each employee in the people array, excuse me, in the employee, in the people array, it's complaining about that. Never mind, that's not going to work. All right, we're going to add something to the paychecks, which is the number of paychecks that we want to print out. This is a really nasty hack. Int number. Okay, now we're going to have a for loop. For int I, which is our index counter, or for int index is equal to 0, index is less than the number, index plus plus, we want to take that people at that specific index, that specific employee, and call the output function. So we're mixing a couple of different techniques here.
I'm going to take that brace out because it's not necessary for it to compile that brace out. Okay. I'm slightly stymied as to why I could not use a for loop on an array of structures, on an array of classes, on an array of objects. And I'm not going to take the time to figure that out. All right, I absolutely want to make sure that everybody gets this far. I don't want to keep going. But I do want to change this output call to something a little bit more interesting. I'm going to delete that people subindex.output. And I'm going to do this. Cout their name, people. Now I wish I'd chosen shorter variable names. People at the index.name, followed by a space $, followed by people at that index, people subindex dot hours times people subindex. When I say sub, I mean subscript wage, followed by an ENDL. Okay, when I ran it, it's kind of hard to pick out our paycheck from the rest of it. So I'm going to add one more thing where it says cout arrow arrow people. I'm going to cout arrow arrow the word paycheck colon end quote and then arrow arrow. The reason I'm doing that is so that that output jumps out from the rest of it. Okay. So when I run mine, I see that 5 paychecks were printed, along with the other miscellaneous output that we have generated from our program. So what's the takeaway from this? I want you to have the idea of a class. And a class is something that can contain data, and it can contain functions, which get renamed methods in this context. Our class has 2 bits of data, 3 bits. It has a name, I shouldn't say bits, 3 pieces of data, 3 members. It has name, hours, and wage. So it's keeping track of 3 elements of data, 3 members of data per object that we create. Our class also has 1 method. It has that output method. You can add as many methods to a class as you want. The way you think of a class is that a class consists of data that is related somehow, and then functions that act upon that data. If you have a book class because you're running a bookstore, then you would need to know the author of the book and the year that it was published and whether you're going to still keep it in stock and how many copies you have on hand, and the publisher and the number of pages and whether it's used or new. All of that would be information. All of that would be members inside the book class. Now what you're supposed to do when you do these, and I skip doing that because we can only fit so much on here, is to make your data private and your members public. Why do you make your data private? Because then you have to provide members that'll set that data. Like if wage was private, we would not be able to do Joe.wage is equal to 1. We would have to use a method to set that wage. Joe set wage, whatever we call that method. Why do you do that? Because then you can validate that the data is more correct. What if somebody typed in a negative value for the wage? This person earns -$1, an hour. Well, it kind of stinks to be them. But
it'd be a good idea if the class had a set wage method and that data was private. The only way that person's wage could be set, that element's wage could be set, was through that set wage function, and it could do some error checking. You know, it can make sure that the wage that was being specified was not less than minimum wage. And you need to do some other sanity checks, make sure it's not more than $1,000 an hour or whatever. Well, I guess if we're the CEO, we can earn anything we want. But, okay, so the class has member variables, it has methods, which are functions that act upon that data. The general rule of thumb is that you make your data private and your methods public. Well, if your data is private, how do you set it in the first place? Well, one way is you can create a constructor that sets those data values. So even if the data was private, then this would work. I could do Sam, you know, and then pass in those 3 values, and those elements inside that class would get set appropriately. Otherwise, you add what are known as getters and setters. More technically, if we feel like speaking Latin, they're known as accessors and mutators. Sounds like an X-Men team or something. So accessors are things that get data out of it. You might want to get a get name function, and a get wage function, and a get hours function to get that data out, which you would have to do if you made those 3 pieces of data private. And you might want to put a set name, and a set hours, and a set wage. So the getters, the accessors, provide access to that data to get it out, while the setters, the mutators, change that data. So we created a class that keeps track of that data, and we illustrated how to create the variable, and then how to access the members inside it using the point. And if I want to change hours, you know, I use the variable name, followed by the period, the point, followed by the member that I'm trying to access. And since we had 3 variables, 3 members attached to our class, then we set them like that. Dot hours, dot wage, dot name. Then we created an alternate way of specifying that data in one fell swoop. We did that with a constructor, so that when the object is being, quote, constructed, when it is being created, we can set the data right then and there. So we don't have to set each one individually. That saves time for the programmer, you know, if there is a way that they can gather that data, you know, and then give it to the constructor. That's a nice thing to do, rather than, you know, because remember when I was listing off all those members of a book class, you know, I listed like a dozen of them. I wouldn't want to have to call books.setName, books.setYear, books.set whatever. You know, it'd be nice if I had a constructor that would accept, you know, something, whether it was just a single string of data or a series of variables like this, to create it in one fell swoop. So after we created our variables, our objects, what is an object? An object is an instance of that class. Instance meaning we have one of them. This is one employee. Joe is an object. He is one employee, capital E employee. Jill is another object. Jill is another instance of the employee class. Sam is a third instance of the employee class. Then we created an array of 5 people, of 5 employees. And we set the elements in that array equal to the objects that we had already created. So now we had a data structure that contained all the data that we've created so far. And then we wrote a function that would accept that array and do something with it. In this case, step through it and print out, you know, their weekly earnings. Typically what you do is you define a structure, a class, and then you write some way to save that data out, you know, whether it's to a database or to a file or whatever. And then you write other functions that will restore that data from the file or from the database. And usually you get to use libraries for doing this kind of stuff. You don't have to write your own database code, hopefully, so that you can reconstitute your thing. So you can issue a single call, you know, with some parameters. I want to get this specific employee that matches employee ID, whatever, and then presto, you have an object that has their name, that has their age, their birth date, their health insurance, you know, everything that you need to know that is stored in that database for that specific record. So you can make a one-to-one correlation between the fields in the database and then the members of your class. Everybody get this working? If not, I'm going to come back and help. Okay.
Sure. For people at home, missed a lot of that there at the end, talking about moving it to the .h file. Okay, so access specifiers. You put one access specifier, and then you list all the variables that meet that access specifier. Private colon, and you list all your data members. And then public colon, and you list all your public functions, all your public methods. You can keep switching between the two, or you could put the access specifier in front of every one of them. You could say private colon double width, private colon double length, private colon Benjamin, private Benjamin, hard. Okay, so access specifiers can be listed in any order in a class. They can appear multiple times in a class. If not specified, the default is private. So when you're doing a class, until it sees an access specifier, everything before that is private. So is this keyword strictly necessary? No. It would assume, it would default to width and length being private. But it's better to list it clearly rather than just to rely on the default, because somebody may rearrange this stuff, you know. Defining a member function. This is telling us to put a prototype in the class declaration. If I was going to add a prototype to my class, I would go to the header file. Where's emp.h? And let's say I wanted a function called get or input. If it's not going to return anything, I would declare it as void. It doesn't accept any parameters. There we go. That's my prototype. Now I actually have to code that. So I would need to go and add some code to that. I would create an emp.cpp file that had the body of that function. I'm going to leave that alone. We're not going to do that. Prototype for a function for a method that will be coded in the emp.cpp file. We're not going to actually do that, but that's what you would do. What would input do? Maybe it would use cout, cout and cin to ask the user to type in the person's name and their salary. So accessors and mutators. The mutator is the member function whose purpose is to store a value in a private member variable. The mutator is also known as a setter, more colloquially. The accessor retrieves a value from a private member variable. Defining an instance of a class. We've seen that, declaring it. I don't know why they're calling it defining there. That's declaring a variable of type rectangle. Avoiding stale data. Stale data is data that should be calculated each time. That total paycheck is data that is calculated based on the hourly wage and the hours that they've worked. We could create a variable called weekly total. And at some point we could go in and we could fill it in with the value of hours times the wage. But then what happens? Somebody changes that hours variable. We have to remember that we're supposed to also go and change that weekly total. So as soon as one of those variables upon which it is dependent is changed, then that variable's data is no longer good. It's no longer valid. The total paycheck variable is no longer good if you change either the hours or the wage. For a rectangle, you have a width and a height, and then you want to calculate the area. Well, if you stored the area as a value within the class, if you created another member called area, then every time you change the width or change the height, then that data would be stale. It would no longer be valid. So data that is calculated, data that should be calculated based on other data elements, make that a function. Don't make it a member of the class. Don't make it, a variable inside the class. Don't make a get area function that multiplies width times height, or make a get total paycheck that multiplies the hourly times the hours. So you should calculate that value every time you use it rather than store that value in a variable, because if you store that value in a variable, then every time you change one of the things that relies on it, you would have to change that as well. Okay, pointers. I haven't talked about pointers. I guess pointers will be the last topic, and we will talk about that on Wednesday before we do our review. Why have private members? If you mark data members private, it provides some data protection. Now that doesn't mean that the data is somehow super safe, that it's encrypted or anything like that. It just controls the way that the code can get a hold of it. The code, in order to change the data, can only access private data through members, through public functions. But you can do some data validation. You can make sure that they've typed in a name that was, not an empty string, or that they typed in an age that was not a negative value, or a birth date that was invalid. You can validate your data, and the more you validate your data inside the class, then the easier it is for the programmer who comes along and uses it, because if a mistake comes up in the way they're using it, they see that immediately. Alrighty, that's a good place to stop. Don't think we have a Dropbox yet. Let's make one.
Is our final, is that next week?
Yes,
Did you ever figure out what day it is?
Wednesday. So we'll review for the final this Wednesday, and we will actually have it next Wednesday.
What are we doing next Monday?
Nothing. We won't be here unless you have another final.
Oh, okay.
Yeah. All right, if you scroll down to the bottom, refresh your Dropbox, you'll see in class P. Go ahead and put your CPP file there, or your whole project if you feel like zipping it.
You did just the CPP, do you also need to have that header?
Yeah, give me the header and the CPP files. Sorry, I was not clear about that. If you're not going to zip up the whole thing, I need the header that you made as well as the CPP.